So now we're going to work on Python as a file, and we're going to look a little bit at variables, modifying variables, printing variables, and conditionals. So the first thing we're going to do is we're going to open up our folder, and if you're on a Windows box, you're going to look at the file, and you'll go down to Open Folder. What you'll do is you'll go into wherever your Python folder is. If you don't have one already, feel free to just make a new one, and you want to open it, and Visual Studio Code will give you access to all your files here. I'm going to delete this file so that I don't use it here. If your terminal did not open down here, make sure you go up into Terminal and New Terminal. It's not going to be huge that we use that a lot right now, but it's going to be used to run our code. So when we make Python files, we click New File. You can name it generally whatever you want, but there are some rules. We prefer letters only. Numbers are possible, but letters only is much preferred. Should be all lowercase, all one word, no spacing, nothing fancy. So I would name it something like my first file .py. And Visual Studio Code may, depending on what extensions you have, change this icon to something recognizable like Python. Okay, so now you see this Python symbol appearing. That just means Visual Studio Code is recognizing my Python. So just to make sure everything's working right, we do print, and that's Python's print command, and then parentheses. Anytime you see these parentheses, you should be thinking input, that print does something and I'm giving it some information. So I'm going to give it the information, hello world. Make sure you quote your strings. You can use single quotes like these apostrophes, or you can use double quotes like regular quotes, or you can even triple quote using these 3 apostrophes. And I believe, let's double check, you can even triple quote the double quotes, not quadruple. So Python has a lot of options for what is and is not okay with apostrophes and quotes. I like single quotes. Most people prefer single quotes, so that's what we use here. In Visual Studio Code, whenever you see a dot up here, that means that your file has unsaved changes. And you might also see it over here if you have open editors. I'm going to save this now with Control S. And notice the dot goes away because I've saved it. To run a Python file, we type in the terminal. If you're on a Mac, we can just type Python 3 and then the name of the file, and it runs the file for you. If you're on a Windows machine, you would type py-3 and then the name of the file. If I run that, I'm going to get an error because my computer doesn't know what py is, but Windows refers to Python as py. If you want to ever clear your line on Windows, on Mac I type clear. On a Windows you would type probably CLS, depending on what kind of terminal you're running. So that's something we can do. We can also write our variables in here. So I can say x equal 1, and I can say print x. I save my changes, and I run my file again, and it gives me the value 1. So I can leave that alone, and then I can say, well, what if I want x to be 2 now? Let me print x now. And I run the file, it prints 1, then it prints 2 on a new line. The big thing to recognize here is that all of your orders are getting executed sequentially. That means that lines earlier in the file get run before lines later in the file. And so that is something that we leverage, and that is a property in a programming language that we tend to like having that feature for us. It makes it pretty easy to figure out how our programs are working. So I'm going to delete that, and I'm going to introduce a new logic construct. Let's have x up here, and x will equal a number 5. And I'm going to introduce what's called a conditional. I will say if x percent sign 2 equal 1 colon print x is odd, else print x is even. Okay, I'm going to save that. I'm going to run it and make sure it works. X is odd for 5, and x is even for 6. Okay, so let's see what's happening here. The first thing to realize is that x x percent sign 2. Remember from before, you've seen that that means take x, divide it by 2, and give me the remainder. So when x is 6, x divided by 2, 6 divided by 2 is 3 with a remainder of 0. So this is saying, does x divided by 2 remainder equal 1? So it's checking a condition. It's not saying that x remainder when divided by 2 is 1. It's not saying that it is that. It's asking, is that? If it is, it's printing x is odd. And this goes back to if you take a number and divide it by 2 and there is any remainder, it's odd. Else, this is, well, what if that wasn't true? Then it will print something else. So when you see something like this, it's basically saying, check my condition. If my condition is true, do this. If my condition is not true, that's what the else means, do this instead. So this is a basic conditional. There's a few things to notice with the structure here. One is that the if and else lines end with a colon. So that's one thing to notice. The next thing to notice, and this is one of the features of Python, is that after the colon, you have lines, and these lines have been indented. It is critical that these lines are indented to the right level. Now on mine, my indentations go to 2 spaces. Yours may go to 4. You may have tabs with no spaces. Indentation can be tricky, so pay close attention to how everything is formatted. Notice how if and else are at the same depth. They don't have any indentation, but their lines are. And so I can actually add more lines here, and I can say print still in if. And I can say here, print still in else. And I can add a line here that says print outside both. So notice that because of the indentation, Python treats these as being at the same level. So whenever this line runs, this line's going to run too. Whenever this line runs, this line's going to run too. But notice how this line is not indented and is after the if else. From before we said that it's going to execute these in order. So this line is going to come after the if else. And because this line is not inside the if else, it should run no matter what. So if I run this with 5 from before, x is odd, x is odd. Still in if, outside both. So I skip the else now, and I go straight to that last line. So that's a simple if and a simple else. And so this is, again, a conditional. But we have other kinds of conditional. Not many. There's one more thing we can really do to this conditional to make it a little fancier, and that's to add other cases. So an example of that would be this. So I can say if x divided by 3 remainder is 1, I can say, or let's start with 0. If I divide x by 3 and get no remainder, I can say x is divisible by 3. But what if I wanted to know if I get a remainder of 1? I can say elif x divided by 3 equal 1. And I can say print x is just a little too big. And then I can say else print x is way too big. And so this is where the if gets a little more complicated. We've added more cases. The thing to realize is that Python will always start with the first case and check until it finds one that matches. So for this one, x equals 5. Is x divided by 3 going to give me a remainder of 0? No, I'm going to keep checking. Is x divided by 3 going to give me a remainder of 1? Well, 5 divided by 3 gives me a remainder of 2, so that's not true either. Then I get to the else. Else means, okay, nothing else was true, do this instead. You don't have to have an else. You don't have to have an elif. It is perfectly fine to just have the if, but you don't have to. So if I run this with 5, oh, it doesn't like something. What does it not like that I've done? Oh, I missed my string. There we go. Now it should be happy. Run the file. X is way too big because I have a remainder of 2. Let's see what happens when it's 4. X is just a little too big because my remainder is 1. And if I put in the 3 here, I get x divisible by 3. Now if I wanted to check this with 4s, I could do something like that. And I could add another case here that says elif x divided by 4, get the remainder, is 2. I can say print x is halfway too big, or something to that effect. And again, we're going to just keep checking until we find one that works, or until we get through everything. It's not going to check anymore. So if I run with 4, it's going to work on this one and do this line, but then it's not going to check these others because it doesn't matter. It's already found the one that works. So one thing to be careful of with ifs and elifs, and I'll give you an example here with grades. So let's make a variable called my grade, and let's say we've had a pretty good semester and it's 95. We can say if my grade greater than equal 90, print a. Elif my grade is greater than equal to 80. Oops. I can say, okay, that's not too bad. Let's print B. Elif my grade is greater than, or I left off an equal earlier, greater than or equal to 70. Print C. Elif my grade greater than or equal to 60. Print D. Else print uh-oh. So I got a 95. If I run this line, if I run this program, I say A. If I change this to a 65, now it tells me D. The problem you might run into is if you see code that looks like this. No, delete the else. This says, if my grade is bigger than 90, print A. If my grade is bigger than 80, print B. If my grade is bigger than or equal to 70, print C. And if my grade is bigger than or equal to 60, print D. So I'm going to run this again, and it still works. But what if I had a different grade? What if my grade was 80? I run the code again, and it printed BCD. Let's see what happened. This is an if, so it checks this. My grade is not bigger than 90. Don't do that. But now this is an if my grade is bigger than or equal to 80. Oh, it is. Print that. But here's where it gets different. Before we said that if you have an if, an elif, another elif, another elif, and so on all the way to the else, it's going to check each one until it finds one. The difference is that these are not elifs. These are new ifs. Python will check every if it sees, but it will check ifs and elifs until it finds one that works. So one of the problems here, notice that we did not catch the problem with our code when the number was set to 65. It still worked with D. But when we changed it to something like 80, it stopped working. But remember before we said that order matters here. So if I rearranged everything and I tried to run this with 80 again, notice I get all the same letters, but the order is different. But if I run this as elifs again, I only get the one letter. It doesn't matter what order they're in when you use your if elif. So it's very important to pay attention to conditions. So there's a few other things we can do here that are pretty important, and that relates to conjunction and disjunction, and or. And we'll talk about that in just a moment.